Hi everyone, welcome to Lecture 4. And in this lecture, we will discover some important discrete distribution. So until that lecture, we have learned what is the random variable and what is the discrete random variables, how we can calculate the mean of them, the variance of them. So, and in this lecture, we will focus on uh, some distributions, some important distributions. But before going to the details, let me explain you what is the distribution and how they can be used and why they are important. So let's say I have some points, okay, some samples like that in a bag, okay. So these points have different values with some different probabilities, right? And imagine that I have ordered them from small to bigger one. So something, and let's say the x-axis is values and the y-axis is probabilities. So, and I have put the points like that, okay, from small to greater one. So it will give me some shape, right? Something like that. So this is actually the distribution of these points. But why this distribution can be important? Because sometimes that points can create some special shape, like this one, okay, like this one. So in this case, if they have some unique shape, we can reveal some formulations to use them to calculate some complex problems. So that's mean if I'm sure that that samples create some distribution, some special shape, that's mean I can use some formulations that are found, and I can use that formulations to create some specific task. Okay, for example, the mean or the variance, I can easily calculate that. So that's why the distribution are important. We will cover some distribution. They are called with some special name like normal distribution, like uniform distribution, etc. So if you heard something like if you heard the samples are or some random variables are uniformly distributed or they have uniform distribution, just you have to thought that those samples with some probabilities form a special shape, okay? And based on that shape, you have to use some particular formulations. So let's start from discrete uniform distribution. So let me define it first. A random variable, let's say x, which takes a finite number of possible values, right? Let's say n different values, and each with equal probability. So if this is the case, we can say that this is a uniform, these random variables are distributed uniform, and it has a uniform distribution. So let me give you an example. When you flip a fair coin, it either shows head or tail, right? And each of them has an equal probability. So then if we encode them as 1 and 0, we can say that the random variable x has a discrete uniform distribution with two possible values. Why? The outcomes are discrete and they have equal probability. That's why x has a discrete uniform distribution. Another example is a rolling die example. A pair die has 6 discrete values, right? And each of them has equal probability. That's why the random variable x has a discrete uniform distribution. Sometimes the possible values, the possible outcomes are the consecutive integers, sometimes not. In the first example, the possible values are not integer, just we encoded them as an integer. But in the second example, the results are integers from 1 to 6. And I can show the x has a uniform distribution with these parameters. So That's mean the uniform distribution has two parameters. The first one is A, and the last one is B in this example. What is the meaning of this? That's mean the X can take the values between A and B, and A and B are included. So that's mean X will be greater than or equal to A and less than or equal to B. So X can take any values between this range, and these values will be integers. So if X has a uniform distribution with the parameters A and B, X can take the possible values A plus 1, A plus 2 until B minus 1 and B with equal probability. Okay, so everyone here are equal alike here. That's why there are B minus A plus 1 different integers that X can take. Okay, so if this is the A and this is the B, remember that the simple formulations to calculate how many integers exist in this range simply do B minus A plus 1. Okay, that's why each sample, each value has a probability of 1 or B minus A plus 1, right? Because remember, we can calculate the probability as 1 over n, and this is the n is the total number between that range. So that's why the probability mass function is 1 over B minus A plus 1. Okay, so for example, if our experiment is rolling a die, we can calculate the PMF is 1 minus E minus A plus 1 if X is 1, etc. So in this case, this will be 1 over 6. Okay. So let me continue. But how we can calculate the cumulative distribution factor, CMF? Okay. So what I say that X can take the values between A and B, and those are included. So anything less than A will have the 0 probability, right? So that's mean X cannot take any values, it will be less than A. That's why the probability will be 0. And also, it cannot take the values greater than B. So anything greater than B will be equal to 1 because the probability cannot be greater than 1. So what if X is in this range, the f of X will be X minus A plus 1 divided by B minus A plus 1. So what is the meaning of this one? So I will explain this operation later, but do you remember the CMF? It will start from something here, and it will round this, and it will round this. So yeah. So these jumps, the individual probability, right? So if I want to calculate the CMF, and if X is 5, actually I have to sum that 5 jumps, right? So that's why I'm using this formulation. But this is a discrete uniform distribution, so X have to be discrete, but if it's not, just hypothetically, if it's not, I can round that values down to the closest integer. Okay, so this is the rounding down operation. Okay, so how we can calculate the expected value of the uniform distribution? So what is the expected value? The expected value is actually the sum of the individual values times its corresponding probability, right? So let's say the K that is the value x can take, will start from A to B, and we have some corresponding probability. So I know this part, right? This is from 1 over n, and this is 1 over e minus a plus 1. So it will be sum of k times 1 over b minus a plus 1. So this is constant, so it will go out, and I need to solve this one. So this case will take the values starts from A to B, right? But I can rewrite this one as this one, right? So let me show. This is the point A. This is the point B. It will take this one. Let's say A. Let's say this is a point 1 from 1. So that's mean from this part, if I subtract this one, I will get this one, right? So that's why I can rewrite this part as sum of k from 1 to b minus sum of k from 1 to a minus 1, give me this part. So if I do some math operation here, for example, let me say this one. What is the sum of the values, discrete values, from 1 to b is simply the b times b plus 1 divided by 2. That is from the calculus class. So same thing for this one, which is a minus 1 times a minus 1 plus 1 divided by 2. It will be a minus 1 times a divided by 2. So if you do the sum math, you will get these values. You will get these values. So when we continue, we can open this part like this one, and finally we will get this result. So you can test you can do it yourself to take this one. So that's mean the expected value of discrete uniform distribution is this one. Okay, so let me show that one. Let's say I have random variable x, which is uniformly distributed between, let's say, 2, 6. Okay, so that's mean it can take 2, 3, 4, 5, and 6. So how many numbers we have here is 5, right? 1, 2, 3, 4, 5. So that's mean 1 over 5 is 0.2, which is the probability of each values. So let's say this is 0.2. This is a probability, this is x. So each value will take this probability, and the total probability is 1, right? What is the expected value based on this formulation? What is my A? This is my A, right? And this is my B. So the expected one is 6 plus 2 divided by 2, which is 4, right? So this is my expected value. So let me calculate in another way, which is 2 times 0.2 plus 2 times 0.2 until 0.2 times 6, right? So what is this? This is a 0.2 times 2 plus 3 plus 4 plus 6, right? And then 5 plus 6, okay? So what is the sum of this one? I think it's 20, right? It's 20, it's here. So 0.2 times 20 will be 4. So as you see, instead of doing this one, I mean, instead of doing all these operations, you can simply use this formulation because this random variables has a unique shape, and this is the shape of this distribution. Okay, that's why we use that simple formulation. So instead, uh, in addition to the mean, we can also calculate the variance with a simple formulation, and this is the formulation. Okay, so let me check that one. So, okay, so what is the let me prove that one. So the variance of x is actually what's this, the expected value of x squared minus expected value of x squared, right? So, and what was the expected value of x formulation is the sum of k from A to B and the k kmf of x, right? So let's make it more simple and let's say the k from 1 to n, okay? Instead of A and B, let's say which is uh, from 1 to n. So how can I open this summation like that one, right? 1 over n, because it will be constant, and sum of k. And what is the sum of um, n integers, which is n times n plus 1 divided by 2, right? Right. So, and this will be, these two terms will cancel each other, and I will stay with n plus 1 divided by 2. So this is the expected value of x. So I know this part, so which is n plus 1 squared. And now let's look at this one. And it will be simple. In this case, I will calculate k from 1 to n, which is a k square pm of x. Okay? So, which is simple again. That is 1 over n. Okay? So this is 1 over n. So I will get 1 over n sum k, k squared. Okay? So what is the summation of sequence squared values? If I'm not wrong, let me double check myself. Yeah, I want to be sure. Um, I think it is. Let me. I think it is n times n plus 1 times 2n plus 1 6. Yeah, it's like that. Yeah. So this term will cancel each other, and I have here this one plus 1 times 2n plus 1 divided by 6, right? So this part is 2n squared plus n plus 3n plus 1 plus 6 and minus n squared times 2n divided by 4. Okay. So if I do some math operations, it will be, I think, um, this is a 4n, and let me, this will be 4n squared times 8n times 2 minus 2n squared minus 6n minus 3, I think. Okay, and divide by 12. So I will get n squared 2n plus 2n and minus 1, I think, right? Divided by 12. Which is, no, I think we did a mistake here. No, we did a mistake here. So let me oh, let me do it again. So which is 2n squared 3n. Okay, so this part is not 4n. This is a 3n. Okay, and finally it will be 6n, and the 6n will cancel each other. We will stay with n squared minus 1 divided by 12. Okay, so this is the variance of the discrete uniform distribution. But how we can get this formulation? What was the, if this is the case, what will be n here? N will be 1 minus b minus a plus 1. Okay, so if I put this one here to the n, I will get this formulation. So this is how we can prove the variance. If please do it yourself again to make it more complete, and we will continue with some other discrete uniform distribution.